as we start looking at vector addition again, now if reviewing vector addition, we've kind of got a pattern as to how we solve these problems. So give me we kind of have 3 steps that we go through to solve the problem. So what's step 1? If we've got vectors that we have to add, right? It says add the following vectors or find the resultant of the following vectors. What's step 1? Find the x and y. So step 1's always break vectors into x and y. And all the vectors, no matter if they're purely north, purely west, whatever, break vectors into x and y. Okay, step 2 then is to do what? You've got your x and your y component for every vector. Now we do what? We add the x's, we add the y's, and then what is our last step there? Right, we build a new triangle. Because by doing this, step 2, adding our x's and adding our y's, that gives us the components, right? The x side and the y side of our resultant vector. So we're not in a place anymore that we really even need to draw out the vectors we're given to see like what's our resultant look like. We can, but sometimes I feel like it's almost distracting as to what you're really looking for in the end, right? It'll give us an idea of what that resultant vector should look like. Is it going to be going northeast or southwest or whatever it is? But I think it can almost be too much to try to draw out our vectors. So I'm going to suggest that from now on, we just solve vectors mathematically unless I ask you to draw them to scale, right? If I ask you to add them graphically, that would be when we use the ruler and the scale and all that kind of stuff. Okay? So let's just start with some here. Let's say that I'm just going to give you the vectors. I don't need to make up the story behind it. Add the following vectors. Okay, 1 is 38.2 meters at 64 degrees east of north, and vector 2 is 46 meters at 13 degrees south of west. Okay, you could draw out what they look like, but I don't really think you need to necessarily, because you've got to make sure the angles are right. You got to make sure they're drawn to scale to give you a really good picture about what the resultant's going to look like. So I don't bother with that step, right? I'm just going to look at them and treat them individually. So if I have to add the following vectors, I'm going to treat them as individuals, and I'm going to start with my first one. I'll just call this V1. It is 38.2 meters at 64 degrees east of north. Okay, so if I'm going to draw out that, I do need to draw out the vectors individually. I just don't need to add them tail to tip necessarily. So east of north means I'm going to draw this roughly in this direction, right? Roughly northeast. And then I've got to decide which way does my triangle need to close. Does it close this way or this way? Right, east of north means that my angle needs to touch the north axis, so that my triangle closes this way. Right, the components of my triangle need to go that way. And so that would be where my angle sits, 64 degrees. And so I might call this side of my triangle V1X, and I would call this side V1Y. Okay, V1X and V1Y. Now I'm going to come down and solve those components. Okay, what do we see is true about X this time? Is it opposite or adjacent? Opposite. It's opposite. So we've gotten kind of into this habit of X always being cosine, right? But that's not always the case. In this case, X is opposite of my angle, so X will be sine. So my hypotenuse here, I forgot to write that in, is 38.2. And so now I'm going to take 38.2 times sine of my angle, 64 degrees. Okay, so make sure your calculator's out and it's in degrees, not radians, times sine of 64, gives me 34.3 meters. And does that need to be positive or negative? positive, right? I'm going to the east there, so it's positive. And then the y component of that is going to be 38.2 times cosine of 64. And that gives me 16.7 meters. Does that need to be positive or negative? Positive. Still positive, right? Both those components were north and east, so they get to stay positive. All right, questions about how we broke that one down? Be really careful with x and y, because you kind of get into a habit of x always being cosine, and that's not necessarily the case. All right, let's look at the second one now. My second vector, I'll just call v2. It is moving south of west. So I'm going to draw it arbitrarily in that direction. South of west means it needs to touch the west axis. And so south of west has to be that angle right there, 13 degrees and 46 meters. Okay, how do we feel about drawing the triangle there? Does that make sense? How we're getting the angles right? Okay. And so I would call this side V2x and V2y. All right, so if I'm solving for V2x, now x is back to being adjacent. So I would say 46 times cosine of 13. And that gives me 44.8. But what do I have to remember with that one? I have to add the negative, right? Have to add the negative. And when we're doing vector addition, just putting west on doesn't do it for us because it's now part of the math that goes into it, right? The negative is going to account in terms of that direction. So we've got to have the negative there. V2y would be opposite of my angle. So I'll use sine this time. 46 times sine of 13. 46 sine of 13 gives me negative 10.3, right? The negative didn't come out in my calculator. I added that because I knew it was going south. Okay, so I've done step one, break my vectors into x and y. And so now I add my x's and then add my y's. I'll just call these, like I said, I like to call them resultant x and resultant y. So VRx would be 34.3 minus 44.8. 34.3 minus 44.8 gives me negative 10.5. And then resultant y component would be 16.7 minus 10.3. Gives me 6.4, positive 6.4. So the negative x component tells me that's going to be going what direction? West, right? I like to draw like a little arrow so I can remember. And then my y component was positive, so it's going to be going upward. Okay, so now I've done step two, add my x's and add my y's. Last thing I need to do here is build my new triangle. So I'm going to get some space up here. Build my new triangle. Does it matter if I draw the x component first or the y component first? No. It does not make a difference. Okay, I'm going to go 10.5, 6.4. And I'm trying to solve now for my resultant. Okay, so that's what I'm looking for, and that's what I'm looking for. So to find that hypotenuse, I'm going to use Pythagorean theorem. So a squared plus b squared equals c squared got me 12.3 meters at. I'm going to use second tangent to find my angle. You got it?
Can use anything.
You could use any trig function, right? The only reason I choose to use tangent is because if I miscalculated my hypotenuse, then I use second sine. Now my angle's wrong too.
So just use a given.
Right. But I mean, theoretically, I calculated these too. So it's possible that my sides are wrong too. But that's the only reason I do that. But No, I don't bring the negative here with me on the 10.5 because the negative just tells me direction now that I'm redrawing it. It's important when we do the math part of it, but when I'm drawing the triangle, it just tells me direction. So I don't want to plug in a negative when I'm doing the math part of it. So if I do second tangent, it would be 6.4 over 10.5, and that gives me an angle of 31.4 degrees. What of what? North of west. Very good, right? Here's my axes. It's touching the west axis, and then we decide, does it swing north of west or south of west? And I think it swings north of west. All right, let's add these vectors. Number 1 is 30 meters per second north. Number 2 is 44 meters per second at 32 degrees east of south. And the third one is 26 meters per second at 15 degrees west of north. Okay, so you've got 3 vectors here. I want you to add these vectors mathematically. Were these the components you had? Or no? Anything switched around, or is that what we had? Okay. You had negative 23 right here. So my x component is positive because it's going to the east. Right, my y component is negative because it's going south, but my x component is east, so it's going positive. So this is what I had for my angle here. You could have also had 43 degrees east of north and would have been an acceptable answer too, right? The complementary angle to that. So had you drawn your final resultant triangle north first, then east, right? It still would have gotten you to the same final position, but you would have been solving for that little angle right there, which would have been complementary to the one I solved for. So this has to stay the same, right? The hypotenuse is always the same, but your angle has 2 options, right? 2 options that could be correct. I'll never need both options. You'll never have to report both, but I'll take either or as long as they're not mixed and matched, right? You can't have can't have an angle with the wrong cardinal directions set up there. Okay, so if it was 43, it had to be east of north, not north of east.